Jai Hind students, myself Nidhi Singh, Assistant Professor in Electrical Department, Ajay Kumar Garg Engineering College. Today I am going to discuss a topic from microprocessor and microcontroller, that is 8255, which is Programmable Peripheral Interface IC. In short, we also called it PPI. So, for any application of microprocessor based system, it requires transfer of data between external circuitry to the microprocessor and microprocessor to the external circuitry. User can give information to the microprocessor using keyboard, and user can see the result or output information from the microprocessor with the help of display. So hence interfacing is used to exchange information between two different applications, or we can say devices. So what is the need of PPI? So this is the basic need of PPI, which is 8255, is a general purpose programmable input output device which is designed to use with microprocessor. It is programmed by the system software so that normally no external logic is necessary to interface peripheral devices. It provides input-output interface between microprocessor and peripherals like keyboard, mouse, sensors, etc. So, coming to the features of 8255, the Intel 8255 is a 40-pin IC. This is a 40-pin IC, and 3 8-bit input-output ports. Port A, port B and port C. So, there are total 3 ports of 8-bit which we have classified as port A, port B and port C. Port C is again divided into 2 4-bit ports, and we named is port C lower, which is represented as PCL, and port C upper, which is represented as PC here U. So, these 3 ports are divided into 2 groups. Now, we have divided these 3 ports into 2 groups, that is group A and group B. So, group A, this includes port A and upper port C, right? We have divided the port C in 2 parts, that is the lower C part and the upper C part. Then we have grouped these 3 ports into 2 groups, that is group A and group B, and group A includes port A and upper port C, and group B, this includes port B and lower port C. And this 8255 has 2 different operating modes. The first is bit set reset mode, which we called in short BSR mode, and the other mode is input output mode. And input output mode is again divided into mode 0, mode 1 and mode 2. So, mode 0 we call it simple input output mode. Mode 1 is called input output with handshake. We will discuss what these are, what the handshake means. Then mode 2 is bidirectional IO data transfer. So, we will discuss all these modes in this lecture. So, first we will discuss the pin diagram. So, here we can see that this is a 40-pin IC, and port A, we can see these are the port A pins. Then here we can see these are the port B, and which comes under group B. So, these are port B pins. Then we can see these are port C, but this is a lower port C. From PC0 to PC3, these are lower port C. Then we can see this is the port C, upper port C, which comes under group A. Then here we can see A1, A2, pin number 8 and 9. This is address line. And then these are the control signal, read, write, then chip select, reset. These comes under the control signals. Then here we will discuss the functioning of all these pins one by one. So, D0, D7, these are bidirectional tri-state data bus lines and are connected with the system data bus, and they are used to transfer data and control word from microprocessor to 8255 or to receive data or status word from 8255 to microprocessor. So, what is the function of this these bidirectional data, these data lines is that they can be used to transfer data, or they are also used to transfer the control word or the status word. Control word is given to the 8255 from microprocessor, and status word is given from 8255 to microprocessor. If microprocessor wants to know the status of 8255, like in which mode 8255 is working, so it can ask for the status word. So status word will be provided by the 8255, and the control word means microprocessor wants 8255 to work in, suppose microprocessor wants 8255 to work in BSR mode. So, it will generate a command word according to that. Now, next is PA0 to PA7, which is port A. So, these are 8-bit bidirectional input output pins and are used to send data to output devices and to receive the data from input output devices. Because these are the bidirectional, it can receive also and it can send also data. It functions as a 8-bit data output latch when used in output mode, function as a 8-bit data input buffer when used in input mode, and it can work in mode 0, 1 and 2. So, these port A, they can be used for mode 0, mode 1 and mode 2. Now, next is port B. This is PB7 to PB0. These are 8-bit bidirectional input output pins and are used to send data to output device and to receive data from input output device. So, it operates in either mode 0 or mode 1. So, port B, it works only for mode 0 and mode 1 only. Then coming to port C, these are again 8-bit bidirectional input output pins, and as we have already discussed, they are divided into two parts, that is PC lower and PC upper. So, these parts individually can transfer data in or out when programmed for simple IO mode, and they are used as a handshaking signals when programmed for handshake. So, as we have seen in some mode we are using the handshaking signals. So, there these pins are used for generating the handshaking signals. Now, coming to the read write signal. So, read, we know when this pin is low, if the bar is there, it means it is a active low signal, means when you will provide 0 here, it will be activated. So, when this pin is low, the CPU reads the data in the port or status word. The next is a write signal. Again, it is an active low signal. So, when this pin is low, the CPU can write the data on the ports or in the control register. The next we have chip select A0, A1. So, chip select is an active low pin which enables the data transfer, and A0, A1, these are connected to microprocessor address line, and combination of these 3 pins decides the port selection, right? This is very important. So, here we can see, one second. Here we can see that if for the CS bar is a chip select pin. So, this should be active to select a particular chip. So, this is the active low. So, to select a chip, 0 should be there, and here if A1 is 0 and A0 is 0, it means we are selecting port A. Again, it will remain 0. If you are working on a particular chip, it should be activated, and if A1 is 0 and A0 is 1, it means we are selecting B. And then if this is 1 and A0 is 0, means we are selecting port C, and if both are 1, it means we are selecting a control register. And the last one, where the chip select is 1, it means 8255 is not selected. So, first the main thing is to first select the chip. So, for selecting chip, here 0 should be provided. Then the reset, this is an active high signal. It clears the control register and sets all port in input mode. So, now coming to the block diagram of 8255, here we can see the first block is data bus buffer. So, through data bus buffer, the bidirectional data buses are connected. Then we have a read write control logics. All the control signals are given here, that is read, write, A1, A0, reset, chip selects. All these signals are connected here. Then we have a group A control and group B control. So group A and B control, these blocks, they receives the control word from CPU, and according to that they issues appropriate command to the ports which are associated with it, right? So with group A, we know that with group A, the port A and port C upper, they are connected, and with port B, group the lower C part and the port B, they are connected. So according to the command word which is received from the CPU, they generate the control signals to all these groups, and here these are the bidirectional input output pins, and accordingly these pins will work. Now coming to the operating modes. So as we have discussed, there are two main modes. The first is bit set reset mode and the second is IO mode. So first we will discuss the bit set reset mode. So bit set reset mode, when the individual bit of port C can be set or reset in this mode. So this mode is basically for the port C, and through this mode we can individually set or reset the port C, and particular bit can be set or reset by writing an appropriate control word in control register. So the control register of this mode is known as BSR control word, and BSR mode, it affect only port C. So only port C, in BSR mode we work only with port C, and it does not affect input output mode. So this is a BSR control word, and this is the control word is of 8 bit. So here we'll see what is the function of every bit. So the first one, or we can say the D7 bit, if 0 to select in a BSR mode, 0 should be there. So 0, this is for the BSR mode. Then these D6, D5 and D4, they are not used. Then we have D1, D2, D3. So these are basically for the bit select, for which bit we want to set or reset. Like suppose here we have given 0, 0, 0, it means we want to set or reset bit 0, and here 0, 0, 1, accordingly whichever bit we want to set or reset, we will number accordingly. Then the D0, this is if we want to set a particular bit, we will provide 1 here. If we want to reset that particular bit, we will provide 0 here. So now suppose, now coming back, now suppose we want to set bit 2, right? We want to set bit 2. So what we will do here? We will provide 1 here. We want to set a bit, so we will give 1 here, and we want to set which bit? Bit 2. So we will give here, for bit 2 we will give here 0, 1, 0, right? So this will be 0 because we are working in a BSR mode. These are unused, so 0 or 1, anything can be provided here, and we want to set bit 2, so we will give 0, 1, 0 here. So 0, 1, 0, and we want to set, so we will give here 1. Suppose if we want to reset it, so we will give 0. So accordingly, our control word will be given to the 8255. Now next is mode 0, or which is also called a simple input output mode. So in this port A and port B, they are used as a simple 8-bit input output port, and port C as 2 4-bit ports. And each port can be used as simply an input port or as an output port. Here output are latched and inputs are buffered, and this mode does not support interrupt or handshaking capabilities. So handshaking capabilities are not included in this mode 0. This is a simple input output mode. The next we will see the control word for this particular mode. So here we can see the D7. This is for selecting the mode, whether we want to work in BSR mode or we want to work in input output mode. So here we want to work in input output mode. So here we will give 1. Here we will give 1. So we will provide here 1. Then next is the D0. This is for port C lower. So if we want port C lower to work as an output, so we will give 0 here. Otherwise, if we want port C lower to work as an input, so we will provide 1 here in this one. Then next is for port B. Again, if we want port B to work as an output, we will provide 0. And if we want port B to work as an input, we will give 1. Then this is port B mode. In which mode, like group B, we want to work in a mode 0, so we will give here 0. If we want to select mode 1, then we will give here 1. The next is port C upper. So port C upper, again for output we will give 0, for input we will give 1. Then for port A, again for output we will provide here 0. If we want port A to work as an input, we will provide here 1. And for group A, if we want this to work in mode 0, we will provide here 0, 0. Suppose we want this to work in mode 1, so we will provide 0, 1. And for mode 2, we will provide 1. Here X means either you can write 0 or 1. So this is how we can create the control word. So here I have taken one example. In mode 0, port A, as we have to generate a control word, if it is a control word for mode 0, where port A is as a output port, port B as input port, port C lower as input port, port C upper as a output port, and then what will be the control word? So here if we see this PCL, this is PCL, port C lower. So in question we can see that port C lower we want it as a input port. So here we will provide 1. Then again we here the port B is again as a input port. So again we have given here 1. Then the group B, it is working in mode 0. So we will provide here 0. It indicates that it is working in mode 0. Then here PC upper. So PC upper, it should work as an output port. So for output port we will give 0. Then port A is again as an output port. So again we will give 0 here. And it is working in mode 0. So we will give 0, 0. For mode 0 we will give 0, 0. And it is not working in BSR mode. It is working in simple input output mode. So we will give here 1. So if we see the control word, this is 1, 0, 0, 0, then 0, 0, 1, 1. So if we see, this is our control word, which is 83H. So this 83H will be given to the 8255 from microprocessor. Now coming to the mode 1, which is input output with handshake mode. So the previous mode, there the handshake shaking signals were not included, but in mode 1 this is a handshake mode, and in this mode input or output data transfer is controlled by handshaking signals. So what are handshaking signals? So handshaking signals, they are used to transfer data between devices whose data transfer speeds are not same, right? So if two devices wants to communicate with each other and their speeds are not same, so first they release the handshaking signals, or we can say these can be the signals to establish the communication between the two devices. So here the two port A and B, they function as a 8-bit input output port. Port A and B, they both uses 3 lines of port C as handshaking signals. So these, as I told you, that port C pins, they are used to generate the handshaking signals. So both port A and B, they use the port C to generate the handshaking signals, and the remaining 2 lines they are used as simple input output lines. So input and output data are latched here, and interrupt logic is also supported in this mode. So, for an example, like when CPU wants to send data to slow peripheral devices like printer, right? So, it will send first it will send handshaking signals to the printer to tell whether it is ready or not to transfer the data. So, when printer will be ready, it will send one acknowledgement to CPU, and then there will be a transfer of data through data bus. So, the signals which are communicated before the data transfer, these signals will be known as the handshaking signals. So, here CPU is sending a signal strobe to ask a printer that it want to send some data, whether it is ready to print or not. Then it will give, if it will be busy, it will send no, it is busy, it can't receive any more data, or if it is ready, it will acknowledge that yes, it is ready. So, CPU will send the data here, right? The next is, so here we will discuss the input control signals of mode 1. So, if mode 1 is working in a input mode. So, there are 4 signals. The first is STB bar, which is a strobe input. The next is the IBF, which is input buffer full. The next is interrupt request, and then we have a INT, which is interrupt enable, and PC6 and PC7, they are used as input output pins. So, this is the format for the status word, and this is the format for the control word for mode 1 as input and handshaking mode. So, now we will discuss the functioning of these signals. So, first is the strobe input. This is, as here we can see, this is a active low for 8255. And this is generated by input devices to indicate the CPU that data to be read is already sent to the port lines of 8255, right? Then the next is the input buffer full. Here this is the active high. This is generated by 8255 in response to this strobe input, and if it is high, then buffer is full and it is not ready to accept next byte. The next we have a interrupt request. It is an active high output signal, and this is generated by 8255, and it is generated to interrupt the processor. So, INTR is generated when strobe, IBF and INT, they all are at logic 1. So, if all these signals are at logic 1, then only the interrupt signal will be generated. And this interrupt enable, this is the internal flip-flop which is used to enable or disable the interrupt. So, for port A, INTA is set or reset by PC4, and for port B, INTB is set or reset by PC2. So, here we can see that we have an input output device here. So, if this input device wants to send some data to the microprocessor, here we know that 8255 is working as an interface between this input device and the microprocessor. So, first this input device will generate the strobe signal. It means that it is telling that it has some data and that data is available at the port of 8255. Then it will generate the IBF. IBF means that the buffer register is full and it can't take any more data now. And then when this 8255 will receive the data from this input device, what it will do? It will interrupt the microprocessor. The interrupt signal will be generated and the microprocessor will be interrupted. And microprocessor, we know that microprocessor, when it will get interrupted, then it will read the data from 8255. So, it will read the data. Now, here the register is now empty. So, again, so when it will be empty, this IBF will be 0. Now, this will know that now it is empty. Now, again it will send the data to 855, and again 8255 will generate the interrupt signal. So, this is how the microprocessor will get the data from input devices through 8255. So, this is a mode 1 port A input operation, and this is a control word. The pattern will be same, and this is mode 1 port A. Here we can see this strobe and IBF. These handshaking signals are being generated with the port C, and when this will be 1, then only the output of this AND gate will be 1 and the interrupt signal will get generated. So, all these three should be 1 to generate the interrupt signal. And this is mode 1, port B input operation. So for port B, PC2 and PC1, they are used to generate the handshaking signal. So, and here PC0, it is generating the interrupt signal. Then we have an output control signal of mode 1. So output signals are output buffer full. Then we have acknowledgement from output devices here. Then we have INTR interrupt request, and then we have interrupt enable. So PC4 and PC5, they are used as input output. So this is a format for a status word, and this is a format for control word of mode 1 as output and handshaking. So now discussing all these output control signals. So first is the output buffer full. This is again, we can see this is the active low output signal, and this is generated by 8255 to indicate output device that data is available. Then we have next the acknowledgement input. This is the active low as input signal to 8255, which is generated by the output device to indicate data from the port has been accepted. Then we have INT, which is internal flip-flop used to enable disable INTR, and PC6 for port A and PC2 for port B controls the INTE flip-flop. Then we have the interrupt 8255, it sets the interrupt indicating that the output device is ready to accept next data byte. So again here we can see that when the 8255 has some data, suppose if it has received the data from 8255, so it will generate a signal OBF. So it means it is giving data to the output devices. So output device, when receives the data, it will acknowledge it. So when output device takes the data, so again 8255 will generate the interrupt signal. It's telling that the output device is now ready to accept the next byte. So then microprocessor will write the data in 8255. So this is mode 1, port A output operation. So the first one is port A output operation, and the second one is port B output operation. Here we can see that PC7 and PC6 and PC3, they are used for generating the handshaking signal, and in port B, PC1, PC2 and PC0, they are used for generating the handshaking signals. So here I have taken one example. Write a program to initialize 8255 in the configuration, and here we are assuming that the address of control word register is 83H, and the configuration is port A should be simple input, port B simple output, port CL should be output, and port C upper should be input. So the control word, right? So control word, we want PC upper as in PC lower and PC upper, both are PC upper lower is the output. So the 0 is given here and PC upper is input. So we have given 1 there. So likewise, we can set the bit or reset. So the control word generated is 98H. So now we will move this 98H to the accumulator. We will load this control word in the accumulator, and then we will send this control word to the this address, which is 83H, and which is the address of the control word register. So we can initialize 8255 in this particular mode. Now coming to the mode 2, which is bidirectional input output transfer mode. So this mode allows bidirectional data transfer, transmission and reception over a single 8-bit data bus using handshaking signals. This feature is available in only group A with port A. So this is available with only group A, and both input and outputs are latched here. Port A uses 5 signals of port C from PC3 to PC7 as handshaking for data transfer, and remaining the PC0 and PC2, they can be used as simple input output or handshake for port B. So this is a mode 2 operation. Here we can see that PC3, PC7, PC6, PC4, PC5, all these are being used for generating the handshaking signals. So this is a mode 2 status word format, and this is a control word for mode 2. So accordingly, we will put 1 or 0 in which whatever the mode we want. So next is find the control word for the register arrangement of the port of Intel 8255 for mode 0 operation, and this is the configuration. So here we can see that according to this configuration, if we put we will set or reset all the bits, we will get 9BH, and the control word register for the above port of Intel is 9BH. Then again next we have taken here we have assumed the control word register address is 23H, and the port is output with handshake, port B is input with handshake, port CL is output, and port CU is input. So if we write the control word for this particular configuration, so we will get AEH. So again we will move this AEH to the accumulator, and we know that through accumulator only we can transfer the data to the output port. So we can send this data, we will out 23H. 23H is the address of control word. It means we are sending this control word to the control word register to initialize the 8255 to work as with this particular mode. So that's all for today's lecture. So this is the reference which I have referred for this particular lecture. Thank you.